Okay, we're going to get the centroid for something like this. Once you have your table figured out for everything that you need, the next thing that you're going to do is you need to choose the pieces that you can work with. The pieces are such that you can easily determine their centroid, and also you can easily determine their area. So here we can break this into two pieces, and each are going to be rectangles. You can choose to break it, let's say this way, so that your two pieces will be the one in red and the one in blue. So you can choose to work with something like this. Other than this, you can also choose to work with it in terms of the one in blue starts from here all the way up to the far end, and the one in red gets to run from here up to there. So this is an alternative method that you can take. Another method that you can take here is to look at it as the one in red being this whole shape, and the second piece being just the part that you don't want, the part that you want to cut out. So this is one way that you can look at it. But either way, you see that you keep on picking just two sections. So this is basically how you always end up with two sections. So depending on you, you can choose which method that you want to use. So let's go with one section running from here all the way up to the far end, and the other section running like this up to here, like that. So take this as segment 1, and we take this as segment 2. So when we go for segment 1, first we need the area of the segment. So segment 1, when you look at it, let's just isolate it. According to what we have there, the length, that looks like a 200 millimeters. From here up to there, this looks like a 200 millimeters. The height of the segment, highlighted by this part, looks like a 50 millimeters. So that is what we have. This being a rectangle, the area can be obtained by rectangle is just LB. So the length being 200, the width there being 50. 5 and 2 gives you 10 with 3 zeros. So that one there for segment 1 comes out as 10,000. Already highlighted the units on top, so no need to keep them. Next up, segment 2. We can also get the area for segment 2. Segment 2 is here. Since the length is initially given from here all the way up to the bottom, our segment only runs from here coming up to the top. So we need to cut out this part here, and this part is 50. This looks like a 250 millimeters. So when we less the 50 for the blue part there, notice that we remain with 200 millimeters as the height. Then the thickness of the segment. According to this part here, this segment is given to have a thickness of 40 millimeters. And being a rectangle as well, we can obtain the area by LB, which will be 40 by 200. 4 with 2 will give us 8, then those 3 zeros. So the area of segment 2 has come out as 8,000 millimeters squared. Any questions up to then? Okay. Next, we need x tilde and y tilde for each segment. Let's start with segment 1 in blue there. X tilde is its centralmost point. So observe that here we're taking the y coordinate, y axis to be there, and the x axis to be here, as indicated by the question. Following that, the x coordinate, we can assume it to be somewhere here. So what would be this value? Since we know it's a rectangle symmetry, so it's exactly halfway of the base. Since the full length is 200, halfway of 200 will have to be 100. So x tilde for that point will be 100. Y tilde, also measured from the bottom, will have to be halfway of this height, since it is a rectangle. So halfway of the height there is a 50. Halfway of that 50 will have to be 25. So that becomes y tilde for that selected section. Having obtained y tilde, now we can get x tilde and y tilde for the second segment. So for the second segment, again, midway will be somewhere here. Now observe that this is a coordinate. We're getting coordinates here. So a coordinate will have to be measured from the x-axis. That will be y tilde. So y tilde will have to be from here all the way up to that point. That will be y tilde. X tilde, however, will have to be just the thickness, basically from the origin up to that point. So it will be the value of x there. This will be a short or small distance. And again, being a rectangle, x tilde will be half of that thickness. The thickness is a 40 millimeters. It implies that at this point, it has to be at 20 millimeters. So x tilde for that second segment comes out as 20 millimeters. Now, again, these are coordinates. Be mindful of the signs. You need to factor in, if it's a negative, give it as a negative. If it's a positive coordinate, give it as a positive coordinate. But the way this question was hinting to say the x-axis at the bottom, y-axis at the bottom there at the leftmost end, notice that each piece is giving us a positive value. The coordinates are all positive values here. The other question perhaps to look at, we'll see how it will be. Maybe it will have those negatives that we see how they come into play. So we have seen what x tilde is, that 20 millimeters. Y tilde, as we saw, it's going to be from here up to that point. Be very careful here. You might be tempted to say it's going to be halfway of that 250. Well, that would be wrong. To get y tilde, first, we know to say due to symmetry, it will have to be halfway of this. And this had a height of 200. So halfway of the 200 would have to be 100 from its base there. So it will have to be 100 from its base. 100 from its base, but remember the base was already 50 above the x-axis. So 100 from its base, you have that 100 from the base there, that's the 100. But remember, already the base was 50 above the x-axis. So the full height, giving us the y coordinate, will have to be that 50 plus the 100. giving us 150 as the x coordinate. As the y coordinate, I mean. So we get 150. I put the millimeters there. We know not necessary because we already have them on top. Are we clear with the y tilde and x tilde for segment 2? Any questions? Okay, looks like we're okay. So from here now, it's just multiplication. So multiply the area by x tilde to get the product here. This is just going to be with 2 extra zeros. So we go to 6 zeros there. The units, you can indicate them in advance as well. It will be, since we have a millimeter squared from the area and a millimeter from the x tilde, this will be a millimeter cubic. In the same way, here we have a millimeter squared from the area and a millimeter from the y tilde, giving us a millimeter cubic as well. So next, we'll multiply the 10,000 by the y tilde. What are we going to get there? Is it this with 4 zeros? Is it that? Kindly confirm.
Yes.
So we do the same thing with the second segment. When we multiply here, 2 with 8 will give us 16. So 1 0 there gives us 4 zeros. Like that. In the same way, now we do 8,000, but now with 150. What will be that product?
$1,200,000.
Like that?
Yes.
Okay. So we have obtained what we needed. Now we can get the sum. So in this row, we're going to get the sum. But we don't need the sum for everything. We need the sum for the area. So the sum for the area, when we add this, we get 18,000. Next, we need the sum for x tilde times the area. So this is going to be 1,160,000. You can verify these as I go. Then you can also get the sum here. Y tilde times the area. And this is also going to be, that is going to be 1,450,123 as well. Is that okay?
Yes.
Okay. So now our formula to get x bar will be the sum of x tilde times a divided by the sum of the area there. So the sum for x tilde and a, we got that value. Over the sum of the areas, we got 18. These will knock out those. What will be the answer here?
$6.44.
6.44?
64.44.
4.44. Since the units are millimeters, so we'll go with millimeters there. In the same way, y bar will be obtained by y tilde so the sum for y tilde times the area came out as this. The sum for the area remains. The 3 zeros will knock out those as well. What will be the ratio now?
$80.56.
80.56. So this becomes the y coordinate, this becomes the x coordinate. So the position or the coordinate for the centroid will now be 64.44 millimeters on the x-axis and 80.56 millimeters on the y-axis. Those are the coordinates. Do these coordinates make sense? Let's see. The full length here is 200. So clearly, x tilde must not exceed 200. It would not make sense to go that far. Other than that, it only makes sense that it's nearer to this. It shouldn't be more than half because obviously there will be more weight this side, more area this side than this side. So it should be less than 100, more than halfway from the origin. So less than 100 there, less than halfway from the origin. Since from the origin that's to the origin that's 100, it makes sense that it is less than 100. Other than that, the vertical one as well, it doesn't make sense for it to exceed the halfway point since obviously there'll be more area at the bottom. So it should be closer to the bottom than to the top. So that 80 we have found places it 50 first from here going up, then plus the additional 30. So here we see that it doesn't even get near that. It will be somewhere here. So the centroid ends up being somewhere maybe here. So somewhere here, this is where we expect it to be. So that becomes our centroid. I did point out 2 methods that you could have used, actually 3 methods that you could have used to get the solution here. Should we look at another or we are comfortable just with this one? I wanted to show you the one where we get to subtract the area. Are we okay or we do that one as well? Okay, so we'll assume you are comfortable with just this one. So let's quickly prepare to look at the next example, which is going to be this one here.